Hey guys, today I'm going to be talking to you about the unit circle. And so I'm going to start in a place I think more people should start when they first learn the unit circle, and that's just considering a circle with a radius of 1 centered about some Cartesian axes and with a circumferencing equaling 2 pi times the radius. And this is the formula for circumference of any circle. And so if our radius is a unitless 1, then our circumference is also a unitless 2 pi in length. So thinking about that circle, we're probably going to need to know a few common angles when we're studying this circle in physics and in math or other subjects. And those angles are 30 degrees, 45 degrees, and 60 degrees. And we'll also need to know 90 degrees and 0 degrees. And we'll need to know these angles and these arms in all of the 4 quadrants. And so when we're talking about these angles, it would also be useful to know the coordinates that each of these angles intersect the unit circle at. So where they intersect over here and where they intersect over here and at all different points on the unit circle. And so how are we going to figure that out? Well, when we think of the point, let's say here for instance, that point is just the x distance and the y distance written in the form x comma y. It's simply a coordinate. And so the question then becomes, how can we figure out these coordinates? And we can figure out those coordinates by using these things called special triangles. And they're special because we can derive the points from them. And I won't derive the points here because that's a long process, but there's a link to it in the description if you're wondering where these numbers are coming from. But for me, I'll just label these points on the special triangles. So our first triangle is 30 degrees, and its x length is going to be the square root of 3 over 2. Like I said, if you want to know where this number comes from, see the description. Its y length is going to be a half. For our 45-degree triangle, the x length and the y length are the same because it's essentially just half of a square here. So its x and y lengths are going to be the same, and so this is also the square root of 2 over 2. And finally, for our 60-degree triangle, the x length is going to be a half, and the y length is going to be square root of 3 over 2. And so you may be saying, well, how am I going to remember all these numbers? And when you look at these numbers, you should actually notice that you only need to remember a few of them. And so the ones that you actually need to remember for the circle are going to 0, 1, then a half, square root of 2 over 2, and square root of 3 over 2. Because if you look, these numbers, except for the 0 and the 1, where the 0 and the 1 are just going to be at these points, and your 90-degree points increments, are actually all the same. And so that simplifies what you actually need to know. So I'm going to clear up the board here a little bit, just so we have some more room to work with. And so thinking about our Cartesian axis further, we can also say that we're going to need to know the positive and negative cases of these numbers. So just negative 1, negative a half, negative square root of 2 over 2, and negative square root of 3 over 2. But the question becomes, how do you know when to treat each as negative? And that depends on where your terminal arm is in the quadrants. Because in the first quadrant, no matter what, both of your coordinates are going to be positive. In the second quadrant, your x coordinate is going to be negative and your y is going to be positive. In the third quadrant, both of your coordinates are always going to be negative, and in the fourth quadrant, you're going to have a positive x and a negative y. And the reason for this, of course, is because in the first quadrant, both of your axes are positive, whereas in the opposite quadrant, both of your axes are negative, and that follows for the other two quadrants as well. So clearing that up, what I can really write is that you're going to need to know that these numbers are both positive and negative. And so if I populate the whole circle with the coordinates that we now know how to find, they look like this. And so the next thing that we need to consider is how to determine the angle of each of these terminal arms. And we could do 9 degrees, but what about if we thought of each of these terminal arms as taking up a fraction of our circle? We could somehow express that fraction as an angle. And that's exactly what we can do using the original statement I made about the circumference being equal to 2 pi. That 2 pi refers to the circumference of the entire circle, meaning that the circumference of a semicircle is then simply pi. However, we can further split the triangle up. Now, let's look at our 30 degrees here, for instance. Now, this is exaggerated for the purposes of the diagram, but this slice here looks like it's taking up about a sixth of this whole semicircle, right? And so we can say that it's taking up a sixth of that pi, because pi is the circumference of a semicircle. And similarly, for our 45 degree, we can say that this looks like it's taking up roughly half of this quadrant here. Or we could also say that it's taking up a quarter of the whole semicircle, right? Because the semicircle spans 2 quadrants. So we can say this is pi over 4. And then for our last one, we can say that this angle here is taking up roughly a sixth of our semicircle. Make that sixth clear. And then when we get to our 90 degrees, that's taking up a half of the semicircle. So we can say this takes up a half. And so now I'm just going to clear this away and label the unit circle with all of those points that we found. And so as you can see here, the angles that we made, you may say, oh wow, I'm going to need to memorize a lot of these. But actually, similar to when we did special triangles, you can see you only need to remember a few of the original angles. And so those angles are going to be 0, pi over 6, pi over 4, pi over 3, and pi over 2. And just like our coordinates, you need to think about these as well in terms of negatives, because we usually define this direction, if you go this direction, as going positive, but this direction is going negative. So if you went to negative pi over 6, you would get to this point. And so thinking about that, we can then write plus or negative these angles. So this is really what you need to know about the unit circle. And so let's do an example problem to see exactly how this fits into what you need to test it on. So first, I'm going to recommend that you pull out a pencil, because the problem that we're going to be dealing with is cos of pi over 3. And I like to use my pencil to imitate where this angle, this pi over 3, would lie on the unit circle. So for instance, let's take our pencil and let's rotate it into that angle. And so as you can probably guess, if we're talking about pi over 3, think, okay, pi over 3, so that's going to be a third of a semicircle. And so let's make our pencil pretty steep, because it's going to be taking up a third of that pi. So if we make it pretty steep like this, that's approximately the same as the angle here. And just think about that in your head. And so then if we draw some lines here to make a triangle, right? A right angle triangle, what we can see is that the x length is significantly shorter than our y length. And so that means that our x length should be the lesser out of these values. And you can ignore the 0 and 1 as I've shown, because the 0 and 1 are only for 90 degree increments. And so you may say, well, I don't know which value is less out of a half square root of 2 over 2 or square root of 3 over 2. So I'll show you a trick to remember that. What you'll want to do is think about your different points. And so if we multiplied each of these numbers by 2, we would get 1 square root of 2 and square root of 3. And so what we can say then is that, well, 1 is probably going to be less than our square root of 2. And if we're square rooting 2 and square rooting 3, since 3 is already bigger than 2, the square root, if we square root both of those numbers, the square root of 3 should be greater than the square root of 2. So that's how we know that the larger angle in our made-up triangle down here is going to be square root of 3 over 2, and that our smaller angle is going to be 1/2. And so then we know that our cos of pi over 3 is still there, and we don't know the answer. So how is this going to help us get the answer? Well, when we think about cos, going back to our SOHCAHTOA, cos is equal to adjacent over hypotenuse, using our SOHCAHTOA, as I said. So then our hypotenuse is 1, because the radius of the unit circle is always 1. And then looking at our triangle here, our adjacent side is this 1/2 side, so that makes 1/2 our answer. So I hope this problem helped you do a lot of problems on the unit circle, and you guys will be good. Good luck!